Hi, this is Mark, and I'm here at JTech this evening. And this evening we're going to talk about transaxles, and we're going to discuss how the power flow runs through the transaxle and some of the more important parts to the transaxle. So first thing I'm going to do is I'm going to spin this around for you, so you can see this is the shift plate mechanism that we're going to take loose, and you'll see the forks and the shift gates as I pull this out. Now, we went through and taken a lot of the bolts out because it would take us forever if we didn't. So one thing I'm going to do now is I'm going to take the shifter plate out so you guys can see it. All right, here's that, and just pull it out nice and slowly. All right, and this is the shift mechanism, and these are your three gates that you use that intersect with the three forks that are inside. The forks are what are going to allow you to select which gear you're going to be in. So we're going to set this off to the side. We won't be using this any more than that this evening, and I am going to separate the case for you now. Looks like we have just a few bolts here, not too many. So we'll take these babies out, and that's that. Okay, now I've got that, I'm going to separate the case, do the best I can without pulling the insides out. All right, and there is our case separated. As you can see in the bottom, we have bearings for the counter shaft and the main shaft and the output shaft. This is the actual stub shaft for the reverse idler gear, which happens to be this gear here that fits in over here when you actually select reverse. So the intent of this is to make sure that with the odd number of gears you actually have an even number of turn. In other words, the input and the output shaft both spin the same direction. Okay, now what we're going to do is discuss real quick the power flow through this transmission. Okay, the general rule of thumb, the larger or the cluster gears are at the top, as you can see here, and this would normally be our input shaft in a standard in a regular transmission, like in a rear-driven automobile. This is a front-wheel drive out of a 98 Ford Contour. So what we have here are your input shaft, which is this one, and we have our counter shaft, which is this one. All right, and the counter shaft is actually going to be our driven shaft this time instead of the input shaft. All right, what happens is on the input shaft, if I can pull this screw apart real quick for you, well, better yet, let me tip it up. This is your input shaft, okay? This is your throw-out bearing for it in order for it to maneuver or manipulate your flex plate for the clutch to come in and out so you can shift gears. All right, that is on the end of this shaft, which is your input shaft. This is actually comes straight off of the engine. All right, your first set of gears on the bottom are going to be first gear, also known as your cluster gears. Okay, your second set of gears are going to be second gear. Your third set will be third gear. Your fourth set will be fourth gear, and your fifth set will be fifth gear. Again, with your idler gear setting up here for reverse. All right, so the way the power runs through this is, first thing we're going to do is we're going to shift into first gear. So we're going to take that bottom rail or the bottom fork, shift it down, and now your power is coming in through the input shaft, through the cluster gear or through first gear, and it's coming up over, but it's coming over and down into your pinion gear, which your pinion gear intersects with your ring gear, and the ring gear intersects with your axles for the drive outside of the vehicle. Okay, so now you can obviously only go into one gear at a time, so we're going to pull this out of first like so, and then we're going to go into second. It's going to be the same synchro. All right, so the synchro goes up, and now your input's coming in the input shaft here. It's coming up to your second gear, which is the next largest gear, which goes over to your next smallest gear on the top. All right, and the thing to remember is as you get smaller gears on the driven gear, the less torque you'll have. The larger gear on the drive gear, the more torque you'll have. So less torque is more speed, more torque is less speed. All right, so what happens is it comes up, it goes into this gear, it comes over, again it goes down to your pinion gear transmits it to the ring gear, and the ring gear again out to the axles. All right, and then pop this down out of second gear, and we're going to go into third gear. All right, third gear will be the next one down. There's third, and it'll be this gear here. Third goes across again to the next smaller gear on the output shaft, and again that goes down to the pinion and over to the ring gear, so on and so forth all the way through the gears. Now when you do this for reverse then comes up, we've pulled this into reverse gear, and now reverse gear is engaged the output shaft. So now the input shaft has come all the way up, it goes through the idler gear sends reverse down to the pinion and out to the ring gear, and from the ring gear out to the axles. So that's pretty much how this works. All right, so I'm going to set that back aside, and now I'm going to remove some of these forks so you'll have an idea what I'm talking about when I'm talking pinions and ring gear. All right, pull that out. This is in it. And we're going to pull this one out. All right, now I'm going to pull these two out together, just like so. All right, be very cautious and lay them down, that way they don't fall over. Number one, mash your toe. Number two, ding a gear and ruin it. All right, this is what your two shafts look like. Again, this is your input shaft. This is your output shaft. And as you can see on the bottom, this is your pinion gear. As you can see, they all ride on taper roller bearings. Those are the best bearings for this because they handle a lot of stress, a lot of load, and a lot of side load. All right, this bearing fit down into this bearing case, and then it engaged with the ring gear, which is right here. All right, this is your ring gear. Pretty self-explanatory. It's again, it's your driving force for the axle. All right, you have tapered roller bearings on each side, again for the thrust and the pressure that these are under. As you can see in the ring gear, you also have spider gears. These spider gears allow your axles up front to rotate at different RPMs, say going through a corner or something. They have to be able, the axles have to be able to do their own thing, or else you have a lot of skipping and hopping of your tires. All right, so with that being said, the last thing we have here is your tone wheel. This actually has 36 little teeth on it, if you will, that this magnet runs over the top of, and they actually send out speed signals to the ECM, and tells the ECM and possibly the TCM how fast the automobile is going. So it can measure its speed, obviously. So I'm going to set this back in. That takes care of that. All right, and I'm going to put the two shafts back in. Should be pretty cut and dried. You got any luck at all. And there we go. And then again, the forks. I'm not going to go through a lot of the effort to put the forks in on video. I just wanted you to see how they operated and what we were using them for and how they are being used. So other than that, I hope this was a decent teaching experience for you. If you had any ideas on how the internal workings of the transmission worked on a front wheel drive. Other than that, I appreciate you watching, and we'll see you again. Oh, by the way, this actually runs, the fluid that this actually runs in is Mercon Type F, or Mercon ATF. So it's just like any other red transmission fluid that you'd have for a Ford. So this doesn't have grease or a heavy oil. This actually has transmission fluid. Again, that's all I have, and I thank you for watching. Have a good evening. All right, man.